Hello everyone, welcome back to Sizabantu PTO LTD, where we learn how to program PLCs, different type of PLC and components. Today I'm going to show you how to program a start delta starter. This is the program that I've previously done before of direct online. You can check on the videos on the description how I did it. So I'm going to just put star delta on my network header. You can check on the other videos on how to create and configure the TIA portal to your main and how to insert or write a program. So as you can see, I'm starting to put in my contacts. Our first contact will be our first network will be just the mains. Excuse me for voice glitches. Sometimes I'm doing this live so that it's practical to everyone what they will face when writing it. So that will be our start, and remember we're using the text from the previous program. It is our start stop. So now we'll include our overload for the mains. As you can see, overload M is for main. Then here you have a main K is for your contacts, and then main on. This is for your contacts are actually switching on, which is your output, and then the K is for the contact, which is normally open or normally closed depending on where you wire it on your contactor. So on network 2, it will be our delta starter. I will say delta contact on or start. This is, remember now we're going to add the on delay. I'll also show you can also use the off delay, but for now we'll use the on delay. I will change my function block to be T0. I'll leave everything on auto, but you can use the manual option I've shown in the previous videos how to use it. And then and also remember, when you are writing a PLC diagram, it's always the best way to have your wiring diagram written down, then you convert your wiring diagram to your PLC ladder logic or your STL or your statement list, depending on the way that you're going to program, but we'll program it all the ways here. So as you can see, the output there will be our delta contacts on. As you can see, it's your output. Then the normally closed contact on it will be our start contact. That means when start is on, then it will switch off the delta contacts from being able to turn on. Then we'll put our mains. On the timer, as you can see, you can use from 5 to 10 milliseconds, not milliseconds, seconds, when you are using a start delta starter. So as you can see, if you just write 7, the PLC automatically is using milliseconds, so you have to convert it and write 7,000, then it will convert it to 7 seconds. I'll just use 7 in this example because of time. Then we'll have our start network. Remember, the sole reason for using a start delta starter is to prevent the high inrush current on your motor, especially on big motors. A motor that is above 5 kilowatts, you can convert that into horsepower by timing by 0.75. So this is our star network. Remember, the star is the one that comes on first, and then it's follows by your mains, and then after that it's delta after 7 seconds. But star and delta and mains almost comes on at the same time. So as you can see, there will have your T0 as your normally close, so that's because it's on delay. Sorry there, because I'll be using a practical example. I'll use a star on. Since for now I'll use the star on to switch off our delta contacts, so that when star is on, then our delta contact will switch off, so that it's practical on our simulation compared to what we'll be doing like physically on the network, because there you will have your contacts, your physical contacts wired, unlike here because we are using a simulator, so you'll need to use your star output to switch off your delta output, and also vice versa, you'll need your delta output to switch off your star output, so that they don't start at the same time. When the other one is on, the other one is off. I'll also show you the wiring diagram. You can pause and view it. This is the wiring diagram for this project. I'll also write the program specifically with this wire diagram, but for now this is how we're going to program it. I've made a mistake there on star. I've put in a contact instead of the output coil, which is supposed to be star on. Remember, K is for the contact. So for now we'll use the star on and delta off to switch off. Star on will switch off delta, and star on and delta on will switch off star on, which are our coils. Then we'll simulate our project. There's also a video on how to import or export your text to our PLC sim, and how to simulate your projects on PLC sim. So I will just expand the screen so that it's viewable to everyone. I think I've switched on the star from the previous project. The star is still on, the start is still on, so I'll just press stop there to stop it. And then this is our project. As you can see, everything is off, so we'll press start now. I want you to check our timer there and check our star. As you can see, star will switch off delta when it's on, and then delta will switch off star when it's on, and the mains will always be on. As you can see, the star is on for 7 seconds. We are counting. After 7 seconds, you see it switches, delta is on now, and then your motor will run on delta. Remember, delta draws a lot of current, that's why we start with star, and delta has more power than star. That's why we keep our the motor that uses more power, it's more preferred to use delta on them. We'll simulate again. This traditional method is usually used on the conveyors, especially that's always running heavy loads. I will also show you the wiring diagram. Now I want to convert this drawing to exactly to be as the wiring diagram that you are seeing right now. Please pause the video and read the wiring diagram properly, and then we'll convert that program to be exactly the same as the wiring diagram. The start delta starter method is preferred because it uses less space in your panel, and it is inexpensive, and it has no limitation, which means it's a continuous run on your motor. And it also can handle the unbalanced load and uses almost 1/3 current on a startup. So as you've seen on the tech table, we have star contacts and delta contacts and mains contacts. Now we're going to use those contacts according to the wiring diagram that you have seen. So as you can see on the wiring diagram, the start should start first, and then as the contactor comes on, the normally open contacts will close. That way we have wired it there. Then it will switch on our mains. And then when our mains are also closed, the normally open contact on our mains, it will energize and it will close, and which will keep our mains running. So here we'll also change this to be a star contact, which will be a normally closed. That means when star is on, it will be a normally open. We also change the delta to wire it to a normally closed contact. And delta is on, our contact will open. And then we also put our overload, which is the secondary side. Remember, you wire your mains on your primary side, and then you wire your star delta connection on your secondary side. This wiring diagram is to prevent you from reducing the lifespan of your motor, because if your mains are always on, even if there is a failure on the star delta side, your main will still have power, which doesn't make sense. That's why you need to switch on your mains using your star contact. That means your main will only switch on after the star contact is on. And then you'll have your overload for the secondary side, and then you have your overload for the primary side. I'll download the program. This is the wiring diagram. You can also pause the video and view it. As you can see there, K3 and KM3 and KM1 is the one that goes to your main, which is your contact from your main and your start. I've forgotten one critical part of our program, which is our start. Remember, start is parallel to your main contact. So you'll have your start there parallel to it. Then we download our program. You can check the video on the description on how to use the PLC sim. One of the disadvantages of using star delta starter is wear and tear, and also the failure of your windings. As you can see, I think our start is still on from our previous simulation. So I'll just pull up my PLC sim and switch it off. And now let me get a proper view where we can be able to see everything, because our program, you can see it has expanded a bit. So we'll press start. As you can see, our star is running. So what will happen, our star, when it's on, the contactor when it's on, our normally open contact will be on. As I've switched it on, and then your timer will start counting. And also, because your mains are on, your mains contact will be on. And then this is all happening in a millisecond. And then when the star is off, our star contact will be off. And then your delta will start running. So this is the proper way to do it, so that you don't shorten the lifespan of your motor, because one of the major disadvantages of a starter, it take a lot of a toll on your windings, because it's a continuous run process. That's why we're using this method in order to save your windings. That's why you'll have to, even if there's a failure on your starter side, then your mains will also switch off. This is one of the methods, or one of the ways to program your starter. I'll also show you another method using the STL, structure text, and function block, and also using the off delay timer. There are many ways for programming. This is a beginner's way of programming. I think it's a better way for explaining it to someone new into programming. This is your program. I'll also show you again the wiring diagram. You can pause and view my wiring diagram that I've shown on other parts of the video. Please like and subscribe, and share the videos, and also comment on what other topic do you want me to touch on my future videos. I do PLC, Mitsubishi, and Delta. Thank you. See you on the other video.